Hi students and friends, welcome to the channel Learn and Teach by Sir Ayaz. In this video, I will talk about the topic properties of metals. The learning outcomes for this lesson are compare the general physical properties of metals and non-metals, including thermal conductivity, electrical conductivity, malleability and ductility, melting points, and boiling points. So first of all, you should know where these metals are placed in the periodic table. Recall the staircase line in the periodic table. This is the staircase line in the periodic table. And all these elements are below staircase line. They are metals. And above this staircase line, we have non-metals. Let's continue the lesson with some general physical properties of metals and non-metals. In fact, I'm going to compare it. Recall that metals have tendency to lose electron readily, which means they form cations. The reason is that they have fewer electrons in their valence shell, and it's easier for them to lose electrons to have stable outermost shell. On the other hand, non-metals have tendency to gain electrons to form anions or negative ions. In this case, the reason is that non-metals have maximum number of electrons in their valence shell. Therefore, they prefer to gain electron instead of losing. The other properties of metals are they are shiny, they are hard, tough, they have high density. And non-metals, they are usually dull, they are soft, they have low density, or you can even say they are lighter than metals. I will continue with this comparison. Now, metals have great tensile strength. Tensile strength, what do you mean by tensile strength? Tensile strength is the ability to bear pressure. Ability to bear pressure. Metals have this tendency to bear that pressure, but non-metals, they don't have this tendency. Due to this reason, they are fragile, brittle, or weak. But the right term is fragile or brittle. Metals are good thermal and electrical conductors. And non-metals are insulators or bad conductor of heat and electricity. Metals are malleable and ductile. Non-metals are non-malleable and non-ductile. Metals have high melting point, high boiling point, and non-metals have low melting and boiling points. So I'll continue with the comparison between metals and non-metals when we talk about the few characteristic properties of metals, like I've just discussed the melting and boiling point. Metals have strong force or strong bonding. Metals have strong metallic bonding. They have strong force. You can even write strong electrostatic force. Force between metal cations and mobile or delocalized electrons. Recall the metallic bonding in metals when you are having this case, that is the metal cations in a sea of delocalized electrons or free electrons. These are metal cations and these are free electrons. So this very strong force, and this force is responsible for metals having high melting point, high boiling point. On the other hand, non-metals, they have weak intermolecular force. Non-metals have weak intermolecular forces, and due to this reason they have low melting point, which means it's easier for to break the bond of force between non-metal molecules. Like if you talk about iodine solid, this is iodine solid, this is iodine molecule, these are the iodine molecule, and these are the forces. I've shown the force with the dotted line. This is intermolecular force. So less amount of energy is required to break down that force. Now let's talk about the thermal conductivity. What do you mean by thermal conductivity? When you talk about thermal conductivity, it means conduction of heat. Heat conduction. Now metals have good tendency of showing thermal conductivity as well as electrical conductivity. For instance, there's a rod here, you can see. On the right hand side, there's a fire. This is fire. We are heating up this rod. What is happening? There are metal atoms in this. These are the metal atoms. And this fire, it heats up these metal atoms. The heat is transferred from this metal atom, and this will continue transferring to other metal atoms. And in the end, the metal rod become hot after some time. Due to this reason that the heat is being transferred by these metal atoms throughout this rod. You can see, and if you hold this rod on this side, you'll feel that heat. This is the reason that metals are good conductor of heat. Now, free moving electrons, so we know that metals have free moving electrons. Free moving electrons also help in the conduction of electricity. Free moving or delocalized electrons also helps in thermal conductivity. Now, comparison between metals and non-metals. Metals, as I just explained, are good thermal conductors. The reason already explained, they have free or mobile electrons, or heat is transferred through vibration of metal atoms. Non-metals, they do not conduct heat. Non-metals are insulators. Non-metals are insulators. So they don't have free or mobile electrons that help them in conduction of heat. Mobile electrons are absent. Mobile electrons are absent. Now let's talk about the comparison in terms of electrical conductivity. Now I've already explained that metal atoms, they have free moving electrons. Recall the metallic bonding. Metallic bonding is this. You have metal cations and free moving electrons. Now, this free moving electrons, they help in the conduction of electricity. Metals conduct electricity. The free or mobile electrons. Non-metals are insulators or bad conductor of electricity. Are bad conductors of electricity. The reason is simple. Free or mobile electrons absent. Free mobile electrons are absent. Now, malleability and ductility. What do you mean by malleability and ductility? Malleable means can be changed into different shapes. Can be made into, can be hammered or made or made into different shapes. Ductile means can be made into wires. Can be made into wires. Now, metal atoms, they have this tendency, if you hit them, they slip or slide over one another. Because the bonding is strong, but the structure is not rigid. You see their wires, this is due to the ductile properties of metals. So you see the different shapes of metals like this nut opener, you have screwdriver, you have keychain, your door lock, you have saw, scale saw. So these all are the properties of metals being malleable and ductiles. Now metals, they are malleable and ductile. Non-metal, they are non-malleable and non-ductile. So metals are malleable and ductile when force is applied metal atoms slip or slide over one another. Due to this reason, they are malleable and ductile, and they can change shape, their structure. Non-metals, they are non-malleable and ductile, non-ductile. The reason is that the atoms, they can't slip when force is applied. Now, I've already explained this. Metals have high melting point, high boiling point. This is due to strong electrostatic force, strong bonding. Metals have high melting, boiling point, strong because strong force, high amount of energy is required to break down the force. Non-metals have low melting, boiling points because they have weak forces and weak intermolecular force, less amount of energy is required to break down the force. So here's a summary of today's lesson. Metal are good conductors of heat and electricity. Non-metals are bad conductors of heat and electricity, or insulators. Metals are malleable and ductile. Non-metals are non-malleable and non-ductile. Metals have high melting points and boiling points. Non-metals have low melting points and boiling points. That's all for this lesson. Press like, share my videos, give comments. For more videos, click the bell icon and subscribe to my channel.